Hello everyone, Mr. Fawcett here, and we were back with another Algebra 1 lesson. Today we're actually starting a new unit, and this unit's going to be all about solving systems of equations using a variety of different methods. So we've already talked about how to solve, different types of single equations with one variable. Now we're going to talk about how to solve multiple equations at the same time, which are called systems, and those are going to have multiple variables, namely an x and a y. Today we're going to focus on how to solve them by graphing, and then moving forward we'll learn some other methods as well. So let's just go through a couple of examples. Directions say solve the systems of equations below by graphing them. So we're just going to look at the one on the left. So this one right here. Well, I'd encourage you to pause the video and take a couple minutes to graph both of those equations. Right? We'll call this number 1 and number 2 individually, and then see what it looks like on the graph. And then maybe it'll help you figure out, what the solution to this system of equations looks like. Okay, I will do the top one in blue. The nice thing about this is it's already in slope-intercept form, so we don't have to rearrange it or anything. The y-intercept is 1, and the slope is, let's make that a little bit of a better point. Y-intercept is 1, and slope is 1/2. And we could just count the change in y, right? Change in y is 1, change in x is 2 if our slope is 1/2. And that gives us another point. And then we would draw a line between these points. And you'll see the more precise you are with your lines and your points, the easier it will be to see what the solution to this set of equations is, or this system of equations is at the end. Let's do the next one in green. So let's maybe change this to blue so we know that's in blue. And I say green, let's do pink, a little bit more contrast. So for number 2, our y-intercept is 4. Our slope is -1/4. So I'd be traveling down 1 and over 4. That puts my second point right here. And here's my line. So a little bit better. There we go. So I think we already start to notice something right away. We notice that these lines share a single point, that point being right here, 4, 3. Well, this is the solution to this system of equations, right? The only point that works for both of these equations is the point 4, 3. Right? That's the only combination of x and y values that would make both equations true up above. And this is what solving a system of equations by graphing looks like. You just graph both of the lines and you look at where they intersect. Okay, that point of intersection is the solution to both of the equations. Let me just show you, again, what I mean by the solution. So if I take this point, right, and let's look at the blue equation first. So I have y equals 1/2 x plus 1. If I substitute in these numbers, so 3 for y, 4 for x, well, 1/2 times 4 is 2. 2 plus 1 is 3. Right? So that point, 4, 3, made the equation true. Now if I do it with the pink equation, y equals -1/4 x plus 4, and do the same thing, I substitute in my x and my y value. Well, -1/4 times 4 is -1. -1 plus 4 is +3. So again, this shows you that this point makes both of the equations true. If we had chosen some other point, it may have made one of the equations true but not the other one, or it may have made both of the equations false, right? So it would not be a solution. So this is the process we're essentially going to follow for every other problem in this lesson. I do want to go down and show you an example where the equations are not in slope-intercept form, because that is going to add an extra step to our process. So let's clear this up. Let's find one where they're not necessarily in slope-intercept form. Okay, let's look at the one over here on the left. So here we have two equations. Both of them are in standard form. So there's a couple of different ways we can graph these, right? We could find the x and y intercepts, substituting in 0 for x and solving for y and vice versa. Or we could put these in slope-intercept form. The latter method, the slope-intercept form method, is the method I'm going to work with here. But you're more than welcome to try graphing it using the intercept method. You should get the same exact line. So let's do this first equation. 3x minus 2y is equal to 14. I want to put this in slope-intercept form, so I'm going to subtract 3x from both sides. Right, I want to make this look like, let me just put this at the top. I want to make this look like y equals mx plus b, because that's very easy to graph. So then I get negative 2y is equal to negative 3x plus 14. And now we need to get rid of that negative 2, right? Well, the inverse operation needed is dividing everything by negative 2. It is important that you divide each term by negative 2, not just the x and the y terms. That's going to give me positive y. Negative 3 divided by negative 2 is positive 3 over 2, or positive 3 halves. And 14 divided by negative 2 is negative 7. So this is the same equation as what we started with, just in a different form. Let's go ahead and graph that. My y-intercept is negative 7. Going down here to negative 7. My slope is 3 over 2, so I'm traveling up 3 and over 2 to the right. And we should get a line that looks, well, let's make it a little better. That looks something like, still not great. Looks something like that though. And again, the better your line, the easier it'll be to tell where that solution is. In fact, this point was just not quite on that intersection. So let's fix that. It's a little bit better. Okay, on to our next equation. We'll do that one in pink again. So I have x minus, oh, it's orange, not pink. So I have x minus 4y is equal to 8. Let me subtract the x from both sides. So that gives me negative 4y is equal to negative x plus 8. I need to divide everything by negative 4. So this gives me plus y is equal to, so negative x is really like negative 1x. And then if I divide negative 1 by negative 4, I get positive 1/4 x minus 2. 8 divided by negative 4 is negative 2. So here is my other equation. Y-intercept is negative 2. Slope is 1 over 4. So I'm traveling up 1 and to the right 4, which puts my next point right here. So I think we can already tell where that intersection is going to be, but let's draw the line anyway. And our intersection point ends up being at this point 4, negative 1. So our solution, the point that works for both of these equations is 4, negative 1. And again, just like we did up above, you could check it just to make sure. Check to make sure that it works in both equations. But it's not necessary, right? You don't have to check it for everyone. I just showed you that that's a way you can be sure that your solution is correct. Now, all the ones here will cross directly on integer points. right? So they're not going to be between, 4 and 5. You're not going to get like 4.2 and 1.1. So all the ones I'm giving you are going to be integer points. So if it looks like it's in between, maybe your line just needs to be drawn a bit better. It is possible to get solutions that are not integers. We're not going to solve those problems graphing by hand. If your solution ends up being, decimals or fractions, there's a way for the calculator to graph that for us. And once we all have access to graphing calculators, I can show you how to do that. But for now, we're just going to graph by hand. Once we learn some other methods, those are also methods that will help us solve problems where the solutions are not integers. Maybe they're decimals or maybe they're fractions. But for today, for this lesson, all of your solutions should be whole numbers or integers. You won't get any fractions or decimals. All right, I think that is going to wrap it up. There are definitely some more problems in this lesson that you can practice on your own, but they all follow the same method we did for these two problems. Until next time, have a fantastic day.